we'll start recording. Okay, so let's come back over here. All right, so we skipped number 1 because we all felt good about number 1, how to convert. Let's go to number 2. Let's see. So it says the real number t corresponds to the point negative 11, 16, and 3 squared to 15, 16 on the unit circle. Evaluate the 6 trig functions of t and write your answer as a simplified fraction if necessary. Right. Yeah. So that's all I'm really using. That's right. Yeah. So the sine is the y value. The cosine is the x value. Tangent is what? Y over x, right? And then once I know those 3, it's real easy for you to cover girl for me to find cosecant, secant, and cotangent, right? Because if I already know sine, take the reciprocal, there's cosecant. I've already know cosine, take the reciprocal, there's secant. I've already know tangent, again, take the reciprocal, I know cotangent, right? And I got to simplify them, right? I got to do that rationalizing the denominator, but yes. Do you guys want me to do any of these? Are we good? Y'all tell me. I'm here to answer questions. So just let me know. We're good? Okay. Let's go to number 3. All right, given the values for sine and cosine, use the reciprocal and quotient identities to find the values of the other trig functions. Again, something real similar to number 2, right? Are we good with number 3? Do y'all want me to do it? Anybody? We're good, okay. Let's move on then to numero 4. Hello. All right, given the triangle, could we find the exact values of the 6 trig functions of the angle theta? SOHCAHTOA, there you go. Yeah, so guys, you know what? I'm glad you brought that up. I thought about it this weekend. Let me see. This is from another one of my classes, from my college algebra. Let me do a new page here. Here we go. So yes, and you know what? I am going to share this on Blackboard, so if anybody decides to watch it later, they can see it. But yeah, and I don't know why I didn't think about that. Thought about it, like I said, over the weekend, and then it just slipped my mind. Have you all ever heard of this before? Anybody? Yes? No? Maybe not? Okay. So there's an expression that we use in trig, and guys, I apologize. I should have told you this when we first started off. I don't know why I didn't think about it. SOHCAHTOA. Okay. So when you look at this part, this means that the sine of my angle opposite over the hypotenuse, right? The cosine of my angle adjacent over the hypotenuse. And the tangent of our angle is the, boom, SOHCAHTOA, right? So, yeah, I don't know why it slipped my mind, probably because I haven't taught trig in 10 years, something like that. But yes, that's definitely something that you're going to use as you're doing, and it's an easy thing to remember, SOHCAHTOA, right? So anywho, let me stop sharing this, and then let me come back to the review. So let's come back to the review. Where are we? Right here. So, okay. So let me make sure that's popping up again. Yes, it is. Okay. So are we good with number 4 then, y'all? We don't need to worry about number 4. Okay. Y'all tell me when you start seeing a question that you're like, hey, can we go over this one? What about number 5? There you go. You're going to find the hypotenuse, and then what are we going to do? SOHCAHTOA again, right? We're going to find the 6 trig functions. Okay. All right. So like I said, y'all tell me when you see something that we need help with. Are we good with this one here? Yeah. Guys, remember, you're going to have the formula sheet. So these would be really easy breezy cover girl to fill in, right? If you had to use it, right? Because you'll have that stuff there. And guys, I'm gonna before we leave for the day, I'm gonna update the formula sheet because I want to tell you what I'm gonna put on there as well. Okay. Let's see. A point is given on the terminal side of the angle drawn in standard position. Find the values of the 6 trig functions. We want to go through number 7. Y'all tell me. So it looks like we might need to do this one, so let's do it. So I'm going to go like this, right? I don't know. Okay, let me ask you a question. My guess, guys, is the settings are the same as when y'all took the quiz. When we took the quiz, did you have to do it all in one shot? Yeah, I don't know. I'll see if we can answer that before we leave. I'll look at the settings and see how it's set up. Okay. All right, let's go like this, and then let me share this part so that it'll come out on the video. Stop sharing this one and come over to this one here. Boom. Okay, and now this should be, yep, it's it. Okay, a point is given on the terminal side of an angle theta drawn in standard position. Find the values of the 6 trig functions of theta. Simplify your answer as possible. Rationalize the denominator if necessary. Okay, let me ask you a question. What quadrant is the point -8 and 15 in? 2, right? So we're going to go like this. Here's my x-axis. Here's my y-axis. We're going to go 1, 2, 3, 4, 5, 6, 7, 8. Somewhere over here, right? Here's -8. And somewhere up here is 15. So this is kind of what we're looking at, right? All right. And so this here is going to be my angle for theta. And so what we're going to try to figure out here, y'all, is if this distance from here to here, if that is a -8, then this one here is going to be a +15. So first thing we need to find is the hypotenuse. Okay, so aren't we going to go x squared plus y squared equals r squared? So -8 squared plus 15 squared equals r squared. So I know that's 64. John, the other day you said you knew what 15 squared was? 15 though, a little higher. Think about it this way, it ends in a 5, so if it's 15 squared, it's going to have to end in a 5, right? Anybody know 15 squared? You can get the calculator. Not that much. So let's go like this. Let me turn this on. 15 squared, 225. 225 equals r squared. Okay, now we're going to add that and 64. Okay, and then we got to take the square root of this number. And somebody said it, 17, right? Okay, 17. So there's our radius, right? Okay, so now that we know that, I'm going to clean this up right here. Now that we know that this number here is 17, I'm going to clean this up a little bit so it looks a little bit nicer. -8. Okay, remember how we're going to do this. Sine of theta, remember, opposite over hypotenuse, 15 over 7, or 17, sorry. Cosine is adjacent over hypotenuse. Okay. Tangent is, anybody remember? Opposite over adjacent. What would I write? Something over something. What is the opposite? There you go. Okay. 15 over -8, right? There's the opposite over the adjacent. Now, I'm going to ask y'all a couple of questions. There you go. All we're going to do is flip them. What's the cosecant going to be then? Boom. 17 over with a negative, and we got all 6 of them done, right? And I'll tell you what, let's do this. Let me come back over here, and let's check our answers. So what was the first one we came up with? 15 over 17. Okay, so let's do this here. So 15 over 17. And well, let me check each individual part, y'all. You know, no, I got to do the whole thing. Okay. And this one I'm going to say was a -8 over 17. And then this one here should have been something like 15 over -8. And this one here was 17 over 15. 17 over 15. And this one was negative 17 over 8. And then this one here should have been negative 8 over 15. Right? And then we'll go chickadee check. And boom, boom, boom. We got them all done, right? I'm sorry, say it again? Yeah, I couldn't tell you, man. I don't know the answer to that. All right, so let's see. So we did our problem. Let me stop sharing this. Let me come back to the review. He would have. He's no longer with us, but he would have. I'm pretty sure he would have. Yeah, so like if you look, guys, there's what, 28 questions? The test has 14. And those 14 questions came straight from here, right? All right, let's take a look at number 8. No, I picked them. Yeah, I picked them. So I went through and I was like, yeah, I'll ask him this one. Yeah, I'll ask him that one. No, I'm not going to ask him this one. No, I'm not going to. You know what I mean? But I picked it from here. All right. Anybody? Y'all need help with this one? Are we good? Let me ask you a question. If I was sitting where you were sitting, or if you were going to do this problem, how would you do it? What would you use? You'd use the chart, right? So you'd come back over here. Oh man, what did I put that chart? Weekly activities folder, right? And then it was probably in 6 maybe. And guys, what I'm going to do this afternoon, I'm going to send you guys an email that'll have the formula sheet again. And so it'll be in your announcements, and this way you'll have easy access to it. But yes, if I was sitting where you're sitting and I was doing this problem, I would say, look, we're looking for the sine of 1/2. They're giving us an aplauso. So it looks like it would be what, 30 degrees and what, 150? So then I'd come back over here and I would say, I guess I got to use this closer, don't I? 30 degrees, oops, not 39 no more. And 150 degrees. And we'd go chickadee check. And we'd have it done. It'd be a lot harder to do, right? That's the whole point of the chart, right? Yeah, yeah. I mean, that's the thing, right? Like, uh-huh. So, yeah, so like look what like so look at the one that, in the example, look what they're telling me. They're saying, okay, how would I find it for sine of theta is equal, I'm sorry, yeah, sine of theta is equal to square root of 2 over 2. What are they telling me? I have to automatically know that the first answer is going to be what number? You got to know at least the first part. You know what I mean? So what is it that you're still knowing? You're still at least knowing the 30, 60, or 30, 45, 60, 90. You know what I mean? You got to at least know what the answers are going to be in quadrant 1, and then you're going to do that reference angle business. Or you use the unit circle, right? Yeah. Okay. But the thing is, you're using something, right? Whether it's a unit circle or you're using a chart, that you're referencing something there, yeah, to figure those numbers out. So yeah, you got to at least know one of them, right? If you can't do the first part, then you're not going to be able to do the second. But yes, you definitely want to use the chart or the unit circle. Okie dokie, artichoke. So look, let's take a look here. Number 9. Okay, it says answer the following questions for y equals cosine 4x. Find the amplitude and period. Y'all want to do this one? Okay, let's do this. Yeah, so look. Very good. So look, let's do this one here, y'all. Yeah, but remember, other people might want it too. Right? So let me do this. Stop sharing this part. Come on now. Come back over here. All right, and there it is. Okay, so let's go ahead and just run through it just to make sure that we're good. Okay, so number one, we're going to find the amplitude, right? So guys, remember the amplitude is the number that's in front of your trig function. In this case, it's going to be what number? Okay, let me ask you a question. That's right. It's the absolute value of that number. That's true. It should be the absolute value of that number, which in this case is 6. But if we had something like this, then we would say the amplitude would be the absolute value of -4, which is 4. That's right. Guys, let me ask you another question. I'm going to keep it a really easy breezy cover girl for us. What is the amplitude of this one? 1, right? If you don't see a number in front, number it's supposed to be 1, okay? Now, let's continue with the second part, which is now we need to find the period. Remember, guys, it's always going to be 2 pi over whatever number b is. And in this case, what's our number b? 4. So we're going to say it's 2 pi over 4, which is the same thing as pi over 2, right? Okay, so now we got that part. My question is, do y'all remember how we would start doing the graphing part? Very good. 0 is less than or equal to 4x, which is less than or equal to 2 pi. And then we would come through and we'd divide everything by 4, right? So we can get our numbers. So this is going to be 0 is less than or equal to x, which is less than or equal to pi over 2. Okay. If y'all remember, wasn't this my first point? And this was our fifth? Do you remember how we found the second, the third, and the fourth point? Do you remember how we did that? Yeah, but what did we set in equal to pi over 2 pi? Not x, but yes, that's right. Good. So 4x is equal to pi over 2. This is going to give me my second point. 4x is equal to pi. This is going to give us our third point. And 4x is equal to, y'all remember the third one? 3 pi over 2, right? Or the fourth one, I should say. Okay. And so now what we're going to do, to get rid of this 4, we're going to multiply by 1 over 4 on both sides. So remember, that is going to cancel. What we're going to end up with now is x is equal to, what's pi over 2 times 1/4? Pi over 8. Good. We're going to do the same thing here. You can think of that as over 1. And this is going to be pi over, good. And we're going to do this a third time. And so x is going to be equal to, isn't that 3 pi over 8? Okay. So, remember what I'm going to do now, y'all? I'm going to make a little table. It's going to look like this. So we're going to have 0, because that's our first one. We're going to have pi over 8, that's our second. Pi over 4, that's our third. 3 pi over 8, and then finally, pi over 2, right? Okay. And then, since our problem was y equals, I already forgot what it was it like 6 cosine 4x? Cosine of 4x, okay. Then right here, we're going to put a 4x, and those are going to be equal to the 0, the pi over 2, the pi, 3/2 pi, and 2 pi. And then was it a cosine or was it a sine? Yeah, it was a cosine. Okay, I'm sorry. Okay, and then so now we're going to say, well, what's the cosine of 4x? Okay. Now, let me ask you a question. Do you remember the cosine of those values? Do you remember cosine of 0? 1, 0, -1, 0, and then back 2? Good. And then what was the number we had in front? We had a 6, right? So then I'm going to say 6 cosine of 4x is, and what am I going to do with these numbers, y'all? Just multiply them by 6. And I could have stayed home. Y'all already know what to do. Okay. So remember what it is I'm really looking at, y'all. When I'm going to do this, these are going to be my x values here. And those right there are going to be our y values, right? So let me stop sharing this business and let me share the review. Okay, so let's come back over here. We said our amplitude was 6. I guess we got to check it. Okay. And our period we said was pi over 2, right? We're going to check that. Good. Okay. And so when I come back to do a little stare and compare, we're looking at 0, pi over 8, pi over 4, 3 pi over 8, pi over 2. And our y numbers are 6, 0, negative 6, 0, and 6. So let me come back over here. Let me get my pencil. So the first one was at 6. And then this one was at 0, negative 6, 0, and then back to 6. And then what do we do? The little graph function one? Yeah, because otherwise we just put points, right? We didn't actually connect them. You got to go through the whole thing again. All right, so now let's go check. And we got our little check. Right? So, yeah. So guys, the one thing I really want to emphasize when we're going through the problem here is, in going through the problem, notice how when we were doing this, what we really went through was we went through the process, right? And I know that it, I had to zoom out a whole lot, but we figured out the amplitude in the period. I think everybody was really good on, right? We were all pretty good on that. I wanted to go through the problem because it's been a little bit of time since we graphed these things, right? We haven't talked about it since we did it back in 4 point whatever this was, 4.5 or something like that. But it's been a little bit of time, and I really want to make sure that we're able to find those 5 points, right? So remember, when we do this part right here, the part that Thomas was telling me about, he goes, we're going to set this part up. Remember, that's finding my first point, and that's finding my last point, right? And then from there, then the way we're going to find our second, our third, and our fourth is we're going to take whatever we have right here, and we're going to set it equal to pi over 2, pi, and 3 pi over 2, right? That's exactly right. That's exactly right. So if you're thinking about in degrees, we found the first one, which occurs at 0 degrees. We found the last one, which occurs at 360 degrees. But we need to find the 90, the 180, and the 270, right? Good deal. All right, so let me come back up to the review, y'all, because again, I want to make sure that we are still good here. Okay, that was what number was that? Was number 9. Let's go to number 10. Okay, tell me, you want to go through it? Y'all feel good? I mean, it's up to you guys. I don't want. It's the same type of problem, but don't we have a shift here? You see what I mean? Like, you want me to go through it? Are you good? So I'll tell you what, let's do it to it. Look, we can probably still do the first part. Anybody know the amplitude? 5. Boom, you know that. Check it. Okay, what about the period? Anybody know what the period is? 2 pi. Okay, I agree with you. Why is it 2 pi? Guys, you're gonna make me cry. This is good. No, this is really good. Like, I feel like the coach on the day of the Super Bowl, somebody throw Gatorade over me because you guys are doing really good. Excellent. Good. Okay, so now let's figure out our phase shift. So I'm going to come back over here, and we're going to do, again, a little bit of copy and paste. Go like this. And let me copy this here. And I'm going to put this in my notes back over here. Boom. And let me zoom in. Zoom, zoom, zoom. And a boom, boom. Okay, we still got to find the phase shift. So, tell you what it is I'm going to do. Yeah, so let's see. Let me come back over here, and I'm going to do this from my perspective because what I have is I've got a folder where I'm putting all my notes for chapter 4. And this is when we did graphs of sines and cosines. So there should be something here that talks about the phase shift, right? Here we go. Okay, so notice what it says. The phase shift is the left endpoint, which is whatever C over B is, right? And when I'm talking about C over B, this is what we're looking at, right? Those parts right there. Okay, so let's come back over here. So remember what we're going to do. It's going to be C over B, right? So we're going to come back over here, and we're going to say, if I do a little stare and compare, do y'all agree with me that B is equal to 1 and C is equal to pi? And we said the phase shift is C over B, which is pi over 1, which is the same thing as pi, right? Okay. Yeah, I'm sorry. Negative pi. Oh, you know why? That's right. That's my bad. That's right. So if you look here, there's a minus in front of it, right? And if I look at my problem, what's in front of our pi there? It's a plus, right? So guys, it has, I'm glad you brought that up, Jennifer. It has to be written like this, x minus c. Since this has a plus here, we can think about that as x minus a negative pi. Does that make sense? Because minus and minus makes a plus. So in this case, c is actually a negative pi, so that'll be just negative pi right there. The parentheses? That's exactly right. Yep. So we're going to go negative pi. We're going to go check. And okay, now let's go ahead and see if we can start graphing this thing. All right. So remember how we're going to graph it. Guys, a little while ago, remember what Thomas said we're going to do? We're going to go 0 is less than or equal to, we're going to take what's on the inside, x plus pi less than or equal to 2 pi, right? And then remember what we said we're going to do? We're going to go minus pi here, and minus pi here, and minus pi here. So 0 minus pi, negative pi, less than or equal to x, less than or equal to pi. Guys, before I go on, I'm going to point something out. Right now, when I was looking at the notes for the phase shift, let me pull this back up one more time. You remember what we said? The phase shift is which endpoint? The left endpoint, right? It's the number over here, whatever this is, right? And if we look at our problem, what did we have here? There's that negative pi as well. Does that make sense? Okay, so remember what we found. We have found our first point and our last point, right? Now what we're going to do, we're going to find the second, the third, and the fourth. So remember, the way we're going to find the second, we're going to say x plus pi is equal to pi over 2. Okay. X plus pi is equal to pi. And x plus pi equals, anybody know? 3 pi over 2. Perfect. Okay. So here's my third and our fourth. Okay, so let's do the second. Everybody agree we're going to go minus pi? Minus pi? Okay. So can I think of this like this, y'all? Pi over 2 minus 2 pi over 2, which should give me negative pi over 2. Perfect. Boom, there's my second point. So far we're doing good? Everybody? Javier, am I doing okay? Just checking with you guys. Want to make sure you're all good here. Minus pi and minus pi. Very good. Boom. Okay, let's do this one more time. Minus pi, minus pi. Again, can we think of this as 3 pi over 2 minus 2 pi over 2? Pi over 2, right? All righty. So now remember what we're going to do, y'all? We're going to make a little table, right? And it's going to look something like this. Remember, our first one was a negative pi. Second one is a negative pi over 2. Third one is 0, pi over 2, and pi. And then what's our function that we got? Let me zoom in here. We have a 5 sine of x plus pi. Okay. So then now I'm going to come back over here. And we're going to put x plus pi, and those are going to be equal to the nice numbers that we already know the values of, right? And we are using a sine function here, so we're going to say sine of x plus pi. Okay. Now let me ask y'all a question. Y'all remember what the sine of 0 is? 0. Sine of pi over 2? 1. Sine of pi? 0. Sine of 3 pi over 2? -1. Sine of 2 pi? There you go. And then let me come back one more time. What do we got in front of it? 5. So again, now all we're going to do here, y'all, 5 sine of x plus pi. Again, all we're going to do is just multiply those numbers there by 5. So that's 0, 5, 0, -5, and 0, right? Okay, now remember, when we're going to do the graph, those are the x numbers we're going to use, and these are the y numbers that we're going to use, right? So, let me stop sharing this, and come back over here, let's share the review. Where is it? There, boom. Okay, so we are starting off at -pi. And we were at, what was the number, the y number? 0. Okay, so I think I know what we're going to do here. So we're going to go here. And then isn't the next one going to be up here at 5, 0, -5, back to 0, put my graph, chickadee check, before you riggedy wreck, and then you got it, right? Good, good, good. Okay, let me ask you a question. Are you glad that we did these two? Do you feel like it was beneficial? Yeah? Okay, good. So guys, remember, I know that we've done through these problems before, right? Every single question that we've done problems similar to this. I just want to make sure that you feel so comfortable with it. Again, I know it's been some time since we talked about how do I graph these things, right? Okay, so let's see. Let's go to number 11. Let's take here, number 11. Use the correct graph with one period of the function, or choose the correct graph period of the function. So cosecant, right? What would I be looking at? If I was going to graph cosecant or 2 cosecant of x, what would I really be looking at first? How to graph which one? How to graph sine, right? So if I was going to, I'm just going to, again, go through this, guys, because I do want to make sure that we're okay with this here, right? And so if I was doing this problem here, and I were to say, okay, look, I want to sketch a graph of this one. Oh, yeah, thank you. Good. You're right. Let's come back over here. Stop sharing that. Boom. Pull this up. I wish there was a way I could just, when I transferred it, automatically started choosing the other one, you know? Okay, so remember, step number 1, y'all, we're going to graph y equals 2 sine of x, right? Okay, so y'all agree that our amplitude here is 2. And our period is 2 pi, right? Because it's 2 pi over 1 in this case, which is 2 pi. Okay, and then since we're just dealing with the sine of x, remember, these numbers are going to be the nice, pretty numbers that we've been dealing with so far, right? And so then we're going to say, well, what is the sine of these things going to look like? Do we know sine of 0 is? 1? Good. And then now, if we have a 2 in front of it, that's right, you're going to put 0, 2. Okay, and then what we would do is we say, look, let's keep this easy breezy cover girl. And let's go pi over 2, pi, 3 pi over 2, and 2 pi, right? And we're going to go 1 and 2, and 1 and 2. And I'm going to do this graph in, let's go purple. Okay, so at 0, we're going to be at 0. At pi over 2, we'll be at 2. This will be here. I'm sorry? Well, you know, maybe not purple, but maybe, yeah, it's a little hard to tell. Okay, so far, this is what my sine graph would look like, right? And then, y'all remember we have these things called the asymptotes? So everywhere we have those x-intercepts, well, it's not necessarily the whole pi. Everywhere you have an x-intercept, there's going to be a vertical line, right? So if you notice there's an x-intercept right here, here's my vertical line, here's my vertical line, here's my vertical line. And I'll do this one in green. And so then this point here is going to look, or this part of the graph will look something like that. And that point of that graph, yeah, will look something like that. It looks kind of parabolic, right? And so the green is really what we're looking for, right? That's going to be my cosecant function. So if I know what this looks like here, and I stop sharing this so that we can come back to review. And if I look at that, does that look like, no. So I know it's not the first one. No. So I know it's not that one. No. What do you think, D? Check it. Did we get it? Yeah, there we go. Okay, is there more to the problem? No, that was it. Continue. Okay. Same thing? Who would be, let me ask you a question. Who would be the first thing I was going to do if I was going to graph this thing? Yes, again. Sine of x minus pi over 4, right? I would graph sine of x minus pi over 4. And then once I got my picture, then we go ahead and do it. You all tell me, guys, I'm happy to do it if you want me to. We can skip it if you want. It's up to you. What do you think? You're good? We're good? You're good as in you don't want me to do it, or no? Okay. Anybody want me to do it? Guys, don't be shy. Javier, are we good? Want me to do it? We're good? Okay, just checking. Remember, guys, this is all about y'all. Okay, number 13. Okay, let's do it. Okay, so I agree with Thomas. He says, let's do it. That's right. So look, I'm going to show you what it is I'm going to do. Remember I told you guys that I was going to update the formula sheet. So one thing I want to point out, y'all, what I am going to put on the formula sheet that's not on there right now. Let me come back over here. Okay, I'm going to put these two tables on the formula sheet as well. Okay. In addition to those two things, and I'll tell you what. Let's do it. Oh, yeah. Because that was one that you were asking about, right? And so when we look at that table, that table really isn't all that complete, right? Because we don't have the 0, we don't have the 90, the 180, or the 270. So that's where these are kind of coming into play. But how do we coming up with that -1? Yeah, that's kind of what I'm referencing. Yeah. So that's why I want to add those to it. Okay, and then you said I mean on the video that I sent out yesterday, right, guys? It was like solve this trig equation, and the answer was like sine of when is the sine going to be equal to -1? And we know that the sine is equal to -1 when the angle is 3 pi over 2, right? Okay, so let me get out of this piece here. Yeah, let's see, did I do it? There we go. Okay, so then we need 4.6. This is the one we're looking for. Because I want to say that in here is where we have our tangent and our cotangent. And I want to say that somewhere in here, did I pass it already? Yes. So guys, this is the other part that I am going to add to our formula sheet, okay? So let me do, actually, I'll tell you what, let me do this. We get this whole dealio here. Copy this. Let's put it on our formula sheet. Boom, right there. Or the work that we're doing, yeah, I'm sorry. But I am going to put that on the formula sheet, okay? Yes, I will. I'll do that right now. I need to make a copy of this part. Okay. Okay, so yeah, we'll make sure that we get both of them on there. Increase that. Okay. So now, John says, let's switch our screens. Let's do it to it. You know, when I try to do that, it shares. Let me see. Let me do this real quick. Come back here. Okay, if I do share the entire screen, let me see. Okay, see how it kind of does this real weird thing, right? But let me see. Let me come back to my notes. And then if I come over here, is it working? Yeah. Okay. Yeah. 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 We'll try it like that. Yeah, that might be better. Thank you all. Okay, so it says, look, man, I already forgot the directions on the problem. Let me come back over here real quick. What is it asking me to do? Select the graph of one complete period of the function. Identify the x-intercept. Evaluate the function for x values midway between the x-intercept and the asymptotes. Okay, so we want to look for the intercept. Okay, so let's come back to my problem here. I just want to make sure something is still working right. Yep, I think it is, right? Yeah. Okay. All right, so let's see here. This is what we're going to graph. Okay, so we want to see if we can find our x-intercept here, okay? So since we're dealing with this problem here, let's see. Look what it tells me right here. It says, find the period pi over b to find the vertical asymptote, solve the equations. Here we go. And, okay, so since I'm using cotangent, right? Cotangent of x, let's see. So y equals 2 cotangent of pi x, right? So just like we did before, y'all, we're going to set this part here equal to, yeah, those numbers right there. So let's go like this. Let's go pi over x equals 0. Pi x equals pi over 4. Pi x equals what? Pi over 2. Three pi over 4. And what was the last one? Pi. Okay, so we're going to find our nice pretty numbers, right? Okay, so y'all agree that we can multiply by 1 over pi on both sides? So here's our first point, we get 0. Point number 1. We'll do the same thing here, 1 over pi, 1 over pi. Yeah, those are going to cancel. That's going to give me 1/4. This is our second point. We do the same thing here, 1 over pi, 1 over pi, very good, 1/2. Here's our third. What do you think this one's going to be? 3/4. This is our fourth point. And then finally, yes. This is our fifth point. Okay, so now that we have that, what I'm going to do, y'all, I'm going to make my chart. It'll look like this. 0, 1/4, 1/2, 3/4, and 1. And then right here, I'm going to put pi x, and those are going to be equal to the original x values that we had right here. those original x values. So 0, pi over 4, pi over 2, 3/4 pi, and pi. So 0, pi over 4, pi over 2, 3 pi over 4, and pi. And then now we're looking at the cotangent of pi x. So remember what I'm going to do. I'm going to be looking at writing these values right here. So that's going to be undefined, 1, 0, -1, and undefined. So right here, I'm going to put undefined, 1, 0, -1, undefined again. And then what number did we have in front? 2. Okay. So 2 cotangent of pi x, that's still undefined, 2, 0, -2, and undefined again. Okay, that's right. So, okay, I wanted to make my chart. Now I'm going to come back, I'm going to look at the original question. And the original question is asking me, over this domain, where do we have our x-intercept? Remember the x-intercept, y'all, occurs when the y value is 0. When is the y value 0? When x is what number? 1/2, right? So what I'm going to try to do, hopefully this works, because y'all tell me it does. And yeah, looks like it's working. Come back over here. So it's going to have an x-intercept of 1/2 and 0. Check it. Boom, we got it. Okay, now what points are midway between the x-intercepts? So if I come back here and I say, what points are midway between my x-intercept? 1/4 and 2, and what else? 3/4 and 2, right? Or -2. Yeah, so 1/4 and 2, 3/4 and -2. So let's come back over here, and I'm going to do my point. 1/4 and 2, and the other one was 3/4, and we said what, a -2? Oops, -2. Let's check it. Boom. Okay, now we want to look at the correct graph. Okay, so let's come back over here. And yeah, we don't necessarily have to graph it, but what I want to show you all real quick, just so you get an idea. Okay, and let me make this a little bit bigger. Here we go. Oh, here we go. Okay, so remember the x values we had were 0, 1/4, 1/2, 3/4, and 1, right? So I'm going to go like this: 1/4, 1/2, 3/4, and 1. So we know that at 1/4 we're up at 2. Right here, we know that at 1/2 we are at 0, and at 3/4 we're at -2, right? This undefined part, guys, remember what this means. The graph, we have these asymptotes. So the graph is like, it's going kind of like this. From here, it's getting really, really, really high. And then from here, it's getting really, oops, I missed that point. Completely didn't. Okay. And then from here, it's getting really, really low, right? Something like that. So in general, that really faint green line is what, or green graph is what my graph should look like, right? So if I come back over here and I say, well, look, that's not it. Doesn't it look like B? So far I'm going to select B, but I just want to make sure. But look, we're at 1/4 and 2, 3/4 and -2. That looks good. And now this one is like shifted over, right? So let's go chickadee check. And did we get it? Pretty sure we did. Good. Okay. And now we're going to do the same thing, but we're going to do it for 1/2, right? Let me ask you a question. Look at this problem right here, y'all. Look at part B. So I can zoom in. Look at part B and look at part A. What's the only difference between part B and part A? That's right. This one had a 2. That's right. So the only thing is we had a 2, now we have a -1/2, right? So when I come back over here, I'm going to say, you know what? Not much is going to change on my graph. Like I'm going to be able to make the same kind of a table. We're going to go like this. We're going to say 0, 1/4, 1/2, 3/4, and 1. This part's still going to be the same, 0, pi over 4, pi over 2, 3 pi over 4, and pi. And cotangent of pi x, that's going to be the same, where that's undefined, 1, 0, -1, undefined again. But now what's different from this one to the other one is now we have a -1/2 right in front of it, right? So look, this is still undefined. This is now a -1/2. That's 0, +1/2, and undefined, right? Does that make sense on how I was able to do that part? Because the only thing that was changing was we now took these numbers right here and we multiplied them by a -1/2, right? Okay, so now let me come back to my problem and let's see if we can find, okay, x-intercept now was at what? 1/2 and 0? Still 1/2 and 0. So right here, we're going to put 1/2, comma, 0. Zoom out a little bit. And let's check it. Good. What are the points that we had for my x-intercepts? I'm going to come back with my graph. 1/4 and -1/2, and 3/4 and +1/2, right? So 1/4 and -1/2. Okay, so we're going to go over here. We're going to use a little point. 1/4 and the -1/2, wasn't it? Okay. Because when I come back over here, yeah, it's right here. So I'm looking at this part down. Yeah, it had a -1/2 in there. There was a -1/2 in front of my cotangent. Yeah, now it's a -1/2. Okay, we're good. So 1/4 and -1/2, and then the other one is 3/4 and +1/2, right? So right here, I'm going to do the same thing. 3/4 and +1/2, very good. And we're going to go chickadee check. Boom. We got it. Okay, now it's asking us to take a look at the right graph. So again, guys, it's not going to be that difficult. Remember what I'm going to do is I'm going to come back, I'm going to make my graph so it looks something like this. 1/4, 1/2, 3/4, and 1. We're good? And then my y values are going between what? 1/2 and -1/2? So let's go like this. Let's say this is 1/2, and let's say that's -1/2, right? Okay, so we know that at 1/4, we're down here. At 1/2, we're here. At 3/4, we're here. So remember what that means. Think about the way the picture is going to look. It's going to look something like that, right? So this right here, y'all, should be the general shape of my picture, right? And I'm going between 0 and what's my ending value over here? 1. So when I come back over here and I say, look, let's take a look. And yeah, which way the graph? Okay, so if you look again, guys, the graph from the left to the right, isn't that graph going which way? Up, right? Okay, so I got to know my graph's going up. This one's going up, but I'm not in the right spots. This one is going up. Am I in the right spots? It looks like it, right? So we're going to say choice B. We're going to go chickadee check. And let's see what it tells us. Did we get it? Did we get it? Did we get it? Looks like we did, right? Good, awesome. Good, good, good. Okay. How would I do this one? What would I use? We could use calculator. Could we also use the table? Right? And the reason why we want to use the table, y'all, is because, let me come back here, do what Thomas said earlier. So zoom out. Where's my identity page? Right here. Yeah, because the reason I want to use the table is because it's asking when is the sign equal to negative 1/2. It happens at 210 and what, 330? So if I come back to my original problem, right, which is right here. Right, but remember what? But remember, it's not cosecant. It's sine inverse, right? So it's not 1 over sine. This is asking me what value of the angle gives me sine is equal to negative 1/2. So what I do is I use my chart. I say, look, here's the first column is my sine. When is the sine equal to negative 1/2? At 210, and it's also at 330, right? So then what I would do is I would come back over here, and I would say, look, let me do a little zoom in somewhere, and all I'm going to do is convert 210 and I'm going to convert those two, right? And so I would say, look, I can get rid of the zeros. Okay, say it again now. Your question is, how do I convert this? I don't know if the calculator will give you both answers. That's why I'm using my table, right? Because it's really easy for me just to look at this and I can see what my answers are, right? So again, y'all, I'm going to do, let me come back to this part right here. So if you want to do this on your calculator, just go 210 over 180. Okay, and then you can convert that to a fraction, 7 over 6. So I know my answer here is going to be 7 pi over 6. And the same thing over here, 330 over 180. And guys, I don't know if y'all have done this or not, but like Thomas, you have that calculated 84, right? Do me a favor. If you have it with you, try doing the 330 over 180 and tell me if it gives you, if it reduces it for you already. Do you already come up with 11 over 6? Yeah. If you do 330 over 180 on that calculate 84, just do like type in 330 divided by 180. Yeah, that's what. Okay, gives you decimal. So there's a button at the top that says math, and the first one should be fraction. 11 over 6, so it's 11 pi over 6, right? Guys, on the other app, I don't know if anybody has that Graph and Calculate 83. At least when I do it on mine, it gives me the fraction. Like it gives me the fraction one already. What it does though, it gives it to me as a mixed number. So instead of like 7 over 6, it would give me 1 and 1/6. But then I know how to make the mixed number into a improper fraction, right? I'm just saying it does it like that for us. So then what I would do, y'all, in this problem, I would come back over here and I would say we have a couple of answers. What do we come up with? 7 pi over 6. And again, let me do the other one. We're only supposed to find one. Let's go through this. I'm just curious because there should be two answers. But that's giving me a positive one. But there's also, oh, you know why? I know why. I know why. Okay, I'm going to come back over here one more time, y'all. Oh, I'm over here. This is what I'm looking for. Yep. Okay. So the reason why we're only going to get one answer is where is this coming from? This is coming from inverse trig functions. Okay. So inverse trig functions. Sorry about this, guys. I can only pick values between negative pi over 2 and pi over 2. Okay. So when I look at this part right here, think about what this is telling me. This is telling me that my answers can be between -90 degrees and +90 degrees, right? So yeah, the first answer we came up with when we did this was we came up with 210. But that's not between negative 90 and positive 90, right? It would be 330, which is 11 pi over 6. But think about it this way. 330, wasn't that also the same thing as negative 30 degrees? That's why your calculator was giving you that, right? So this here should be a negative pi over 6. That's what my answer is going to be. Okay. So when I come back over here, where's my, trying to find my problem? Here we go. We should just end up with a negative pi over 6. So let me go like that, negative pi over 6. Maybe check. And we got it. And I want to see something here also, y'all. Like John was saying about we use our calculator. So I want to make sure I am in radian form. Oh, here we go. Yeah, I'm in radian form. Okay, so let's exit here. And if we go second, sine inverse of, what was it? Negative 1/2, negative 1 over 2. Boom. It's going to give me that, which is, that's probably the negative pi over 6. If you want to double check, you can go like this. Yours came up with negative 30? Okay, because you know why? Yours is in degrees, right? So look, if I go to mode, yeah, and you know what? I would actually say, I would actually probably keep it in degrees. You know why? Because if I go sine inverse of negative 1 over 2, oh, sorry. Okay, let's do this. Second, sine inverse of negative 1/2. Okay. So yes, mine is giving me negative 30, right? And John, you said your calculator, did it come up negative pi over 6? It did? Okay. So your calculator is a lot newer than this one here. That's like an, what is that, TI what? Inspire. Okay, so that's a newer calculator. 83 plus is pretty old school. Okay, so yeah, you got something much more advanced. Jennifer, what kind of calculator do you have? 83 plus? Okay, so yours is exactly the same thing that mine is coming up on here, right? So I would probably keep it in degrees, Jennifer, because now I know how to convert negative 30 to radians. You know what I mean? And when I do it in radians, look at the answer it gave me. It gave me that negative 0.5, right? It gave me some rowdy, ugly looking decimal. And off the top of my head, I'm not going to know that that's negative pi over 6. You know what I mean? But if I know negative 30, I can convert that real easy. Yeah, good deal, good deal. All righty. So guys, I'd probably do this one exactly the same way. I would, so let me do this. I would do this the same exact way. So let me copy this here. Let me paste this in my notes. And let me zoom in because we're really zoomed out. There we go. Okay, so if I was doing this problem, y'all, first thing I would do, I'd move that pi over 4 over there. So that's going to give me 3 arc sine of negative square root of 3 over 2 is equal to a negative pi over 4. Oh, wait, you know what? My bad. Sorry. I'm getting ahead of myself here. Okay, my bad. I need to first find this. I was thinking about this differently. Okay, I would first find that. What's the arc sine of the negative square root of 3 over 2? So I'm going to use my calculator, arc sine, sine inverse of negative square root of 3 over 2, right, like this, negative 60 degrees, right? Okay. I did. Oh, okay, because I'm doing this in pieces. Before I do the 3, I want to find out what's this number going to give me first. Okay. So yeah, so look, we got negative 60, right? So negative 60, let's convert that to radians, okay? That should be a negative pi over 3, right? Okay, so look, what do we have now? 3 times negative pi over 3 plus pi over 4. What's going to happen to these right here? So can I think of this as pi over 1 plus pi over 4? Okay, what's my common denominator here? 4. So we're going to go 4 here. Oops. We're going to go 4 here and 4 here. So that's going to leave me with a negative 4 pi over 4 plus, I'll think about this as a 1 pi over 4. What's that going to leave me with? Boom. And then I'll come back to my problem. Right here, we will put negative 3 pi over 4. Do the chickadee check. Right. So yeah, guys, again, if I was sitting where you're sitting, this is just me. I'm much more comfortable with degrees than I am with this, because I know, like, to me, it's easier for me to do the computation than it is for me to, like, remember when we did the sign of a sum or the sign of a difference? So, but you said, okay, can we find the sine of 15 degrees? Then we can say, well, I know I can write 15 degrees as 45 minus 30. But if I had 15 degrees, which would be, say, pi over 12, and I would say, okay, what's another way for me to write pi over 12 using like pi over 6, pi over 3, pi over 4? That is much more difficult for me to figure out how to do than it is if I'm dealing with numbers like 15, right? Because I know I can do 30 minus 45. Does that make sense? The English? There you go. So that's exactly how I would do these problems too. I would say, look, let me do it in degrees. Now, John's calculator, and I don't know if anybody else has an Inspire, but if you have an Inspire, obviously it's like giving you the number, you know what I mean? It's not giving you the decimal form, it's giving you the nice pretty pi over 6 type of thing, right? Or right, it's giving it to you like that. But like on the app and on my calculator, and like what Jennifer has, because she has the same thing I'm coming up here. Javier, what do you got? Which is yours? Oh, you're using a Casio. Does yours give you pi over 6s and stuff like that? There you go. Okay. Give you the answer. Yeah. Okay, so you can figure those kind of things out, and it'll work for you. Yeah, definitely. Okay, so look, let me move on here. So guys, we still got about an hour. And remember, on Monday, I'm going to cover 6.1. Guys, 6.1 is not that long of a section. No, it's not on the test, but I'm just going to do, the reason why I want to do 6.1 on Monday is so after that, if you say, hey, sir, we didn't get to finish this problem on the review or that problem on the review, can we do it? We'll have some more time, right? So this also gives you time, guys, between today and Monday to keep working on the review so that when we come back on Monday, sir, how do I do this one? How do I do this one? How do I do this one? Yeah, on Mondays, I'm here, guys, at 1 o'clock. What do you think? We good with this? Okay. The answer is 1? Are you sure?
Yes, because begin becomes 1 over sine, and then cosine becomes cosine over sine, so then everything comes out and that's 1 over 1.
Okay, so let's see. Let's just make sure we're good. All right. So look, I'll tell you what. Let's do this. What's another way for me to write secant? Not 1 over sine. There you go. Okay. We already know sine x is just sine x. What's another way for us to write cotangent? Cosine x over sine x. Okay. Now, Thomas says, look, we can get rid of the cosines, right? And we can get rid of the, what's the only thing we're left with? 1 over 1, which is the same thing as 1. So we come back over here. We're going to put numero 1. We're going to go chickadee check. Am I checking? There we go. Boom. There you go. You got it. Right? Okay, so you already knew. You already knew. Okay, good. Yeah. Okay. All right. So I'll tell you what. Let's see if we can figure it out. We're gonna go super slow. All right. So look, let's do this. Boom. And like I said, y'all, remember, we're gonna have time on Monday also to go over stuff. Right. I'll be here an hour early. On Mondays, I'm always here by 1. But remember, Monday we'll have time. So like I said, 6.1, guys, super short. I think you have like 6 or 7 problems in the homework. Shouldn't take too long. And I'm going to make that homework due not the following Monday, but the following Wednesday. Because really what I want y'all to worry about next week is the test, right? So when we come back to, remember, guys, Monday we're going to meet here, right? I'm going to do 6.1. I'm going to say, hey, what questions do you have from review? We'll go over those. Then on Wednesday, we're not going to have class because that's me giving you the day to do your test. The following Monday, I'll continue with chapter 6, but instead of 6.1 being due that day, it'll be due Wednesday, okay? All right, so look what it says here. Verify that the equation is an identity. So yeah, y'all, the first thing I'm going to do here, I'm going to come back up here. I'm going to look at my fundamental identity chart because there should be something here about even and odd functions. Look what it tells me about the cosine of negative x. The cosine of negative x is the same thing as cosine of x. Okay, so we're going to say this right here just because becomes the cosine of x, right? But what did I have in front of it already? So I got to keep it there. Plus secant of x, okay? All right. First thing I'm going to do, y'all, I'm going to think about this as negative cosine of x over 1 plus, can I think of secant as 1 over cosine x? Okay. Now, if I want to get these two together, do y'all agree that we need to get a common denominator? Okay, so we're going to multiply this one here by the cosine of x and this one here by the cosine of x. So this is going to give me a negative cosine squared x over cosine x plus 1 over cosine x. Okay. Now, I'm going to rewrite this, y'all, as 1 minus cosine squared x over cosine x, right? I'm just kind of switching these two around. I'm putting the 1 first and then the minus cosine squared x second. So, yes. I'm sorry. Jennifer, you're right. John, are we good? Okay. No, you're good. You're good. I'm just making sure we're all good here. Jennifer says, look, guys, 1 minus cosine squared x is the same thing as sine squared x, right? Okay. Now, do y'all agree that sine squared x really means that we have sine x how many times? Twice. Okay. And what are we trying to get to? We're trying to get to a tangent and a, do y'all agree that this piece right here is, and there's our tangent x sine x, right? Okay, so look what we're going to do. I'm going to look at exactly what we have here. Okay. Well, hold on. Let's go. Let's hold on. Look, before we do that, let's go super slow. Okay. Look, what was the first thing we did here? We got rid of the negative on the inside because using the what? Even and odd? Okay, so let's come back over here and say, here we go. We can write this as minus cosine, where's cosine? Right there, x, oops, a capital X, plus secant x, or secant x. And we did that using the odd and even. Validate it, we're good. Okay. Now, what we did from here is we said, look, this is the same thing as negative cosine x. That's right. Plus 1 over cosine x. And we did that using the reciprocal rule, right? So just to double check, guys, you can always come back over here. Yes, reciprocal rule, validated. Okay. Now let's come back and let me look at my notes. What do we do next? We did algebra. So I'm actually going to write it. No, I won't go straight to sine. because remember, that involves me saying, don't worry about this, don't worry about this, don't worry about that. That's too many steps to skip. What I would probably put is something like this one here, 1 minus cosine squared over cosine x. So I'd probably put something like, let me do my fraction, 1 minus cosine squared of x over cosine x, and this is algebra, right? Okay, thank you. Okay, validate it, good. And now, can we put sine squared? Very good. That is the Pythagorean identity. Okay. And then here, I would probably write this as, yeah, okay, so let's go ahead and put tangent x. And we'll put, what do we say, quotient rule? Validate it, and we got it, and check it. Everything is good.
Will it ever let you validate this type of the proof is valid and valid isn't right?
I don't know.
For like these problems, we can check on like it's not like this, you got one type of
That's right. Didn't we do that one day in class? We're doing a problem, and it said that's not correct. Like, I think we skipped. We tried to go. Remember a little while ago, John, when you said, okay, like from here, let's go straight to sine squared. That's doing too much, because then we're skipping all this, and we got to at least show a little bit of the algebra. So I think if we would have done that, let me come back to my problem. If I would have done that from here, like if I would have gone from this step directly to this one, it would say that's incorrect. So I have to go back, it's not going to let me go from one step to the next if I'm trying to do too much in one thing. Yeah. So y'all, one thing I told you guys was, when I taught pre-cal in Austin, at that time we were offering a trig class. So when we did trig, we did more like, let's do application problems with trig, as opposed to what is the sign? Oh, it's the opposite of hypotenuse. We didn't go over that because we had already had a trig class. When I did teach trig, which was 2006, 7, 8, 9, I don't know what y'all were doing that time, but I wasn't using my lab or anything like that. I don't even know we had my lab at the time. So everything, when I was grading all this stuff, everything I was grading by hand. And that's what I was saying, like, what I'm really grading are the steps. How do you get from this part to this part? Which is kind of what I'm trying to show here. This is what I'm really grading, right? So I have to be able to tell that from one line to the next, you can't try to go too far down. Like, you really don't want to, like, if you were doing this at home on pencil and paper, say we were back in like 2007, you really wouldn't want to say, oh, let me do some scratch work and then let me just put my answer here. Your answer really is that scratch work. So you just kind of you might want to clean it up a little bit, but you really want to go step one. Okay, and if you think, oh, I don't need to put all this, put it anyway. It's better to do it than to go step one, let me skip all this, there's step two, because then that's too big of a leap. You know what I mean? It's too big of a leap to do it. So, yeah, like I said, this is my first time doing like a trig stuff on like on what we call an LMS, a learning management system, like a computerized system. Before that, it was always,
You think all that is better, or do you think
for algebra, I think for algebra and like what we call developmental math, like remedial math, it's really good. You know why? Because think about, instead of doing a problem like this, you're doing like, say, just an arithmetic problem, right? Or you're doing a simple algebra problem. What do? You hit try another. And you do it as many times as you need to understand, okay, I know the process now, I can do this. For something like this, I still think it's good, but it can be tedious, like we were saying, right? Sometimes, like Thomas said, it's a little finicky at times, right? The way they're asking me how to write the answer. Well, remember, you're still going to do the right answer, right? So look, I didn't worry about what they wanted. I wrote out everything like the way I was going to do the problem, and then once I write that out, then I'm thinking about, okay, how do they want me to write it? You know what I mean? how do they want me to write it? And if you notice, like I didn't show this step here or that step there, but I didn't go directly from, I'll be with you right now, John. I didn't also go directly from, or so I'm not, sorry, not that one. I didn't go directly from here to there either. I had to do a little bit of something.
Would you prefer it like this, where you show every single step, like when you were grading the paper back in 2007?
It was easy. It was easy for me to do. It was definitely easy for me to do. But just like when we had, like, I think it was class assignment 1 or class assignment 2, some people, it was like I'm reading and I'm like, I don't know what you're doing here, right? I don't know how you got from this step to the next. Or if you're doing something that you cannot do, like mathematically you can't do that, then that's where it gets a little bit more challenging. So those of you who got like 100 on those assignments, it was really easy for me to follow through. But if you were skipping steps, or you did something that you can't do, or you went like from, like if some people would try to go from here to there, or from here to there. I mean, that's the question. How do you get from here to there? Like, I don't know what you did. Well, I just wrote it. That doesn't help me. You know what I mean? And then more importantly, it doesn't help you guys either. All right, let's take a look. You guys stuck on the next one? Okay. This one here?
Yeah.
Okay.
I don't know how it's like separate them into two different things, and then I did it, and then the computer kind of wrong and did another like setup, like whatever, and I was like, but I got the same answer. Like, I don't know, it turned me off.
Okay. So take a look here, y'all. It says use the addition or subtraction formula to find the exact value. Write your answer as a single fraction in simplest form. Jonathan, this is one you were asking about the other day. It was similar to this one here, except, I'm sorry? Oh, sorry, man. Sorry, Christian. Christian, this is the problem that you were asking about the other day on Monday in class, except yours had radians, right? But it's the same type of a problem. So guys, I want to show you something here. If I look at that part right there, that cosine of negative 225, if I come back over here and I look at my fundamental identities, do you agree that, could we write that as just the cosine of 225? What do you think? Because of the negative or even and odd identities? So if I were to come back over here, I should be able to write this as just the cosine of 225, okay? Okay, I don't have to write it that way, but I'm saying that I could do it that way too, right? Now look, if I come back over here, think of the number we're trying to get to. We're trying to get to 225 degrees. 225 degrees? Is that what it is? Okay, or 255, I'm sorry. It's 255. So, yeah, I just wrote the wrong number in here, 255. Okay, so if I come back and I look at my sheet here, if I'm trying to get to 255, how can I come up with 255 using these numbers here? Is there a way I could add any of these numbers or subtract any of these numbers and come up with 255? Very good. So y'all agree with John that we could say this is 30 plus 225? Okay, so look, let's come back over here. So John says, look, we can write this as the cosine of 30 plus 225. Okay. Now, because we're going to use either the addition or subtraction, we're using the addition in this case, I'm going to come back over here and I'm going to look for my cosine of a sum. Where is it? Right over here. Right there at the top, cosine of u plus v is cosine u cosine v minus sine u sine v. So we're going to say this is going to be cosine 30 cosine 225 minus sine 30 sine 225. 225, right? So far we're good? Yeah, because right now, how do we do this? John suggested, why don't we take 30 and 225? But we could have used, the answer will be whether you use a sum. Right now we're using a sum. We could have done a different thing. We could have figured out what numbers, if I subtract them, would give me that 255. But John's intuition said, let me just add those together, and there's my 255, right? That's right. That's right.
numbers.
But the numbers that you choose shouldn't make any difference. You should still come up with the same answer. But look, let's go through it and see if we can't make sense out of this, okay? So look, we have, if I come back to my notes, we have cosine of 30. What's the cosine of 30? Now, look up here. Square root of 3 over 2, right? So right here, y'all, I'm going to put square root of 3 over 2. Cosine of 225 is negative square root of 2 over 2. Negative square root of 2 over 2 minus sine of 30 is 1/2. And sine of 225 should also be negative square root of 2 over 2, right there. Okay, and so now let's take a look here. Everybody agree on the top, this is going to give me a negative square root of 6 over 4. Isn't this one here going to be a positive square root of 2 over 4 because we got a negative and a negative? Okay, so y'all, this should be something like the negative square root of 6 plus the square root of 2 all over 4. Am I good like that? Okay. So, Christian had this problem the same on Monday, something similar to it, right? Except yours had radians. And he was entering his answer like that, right? And it was like, hey, that's not right. We're going to check something. I'm going to see if it's going to work this way, and hopefully it does. And if it doesn't, then I'll tell you what I think the issue is. So we have a fraction, and we have a negative square root of 6 plus square root of 2. All of this is over 4. And let's go check. And let's see what it tells us. Okay, it tells me we're good. I'm going to try something else, y'all. I'm going to try another one. I'm just curious. Okay, yours wasn't this the same one you had? Do you remember? If it wasn't like this, it was still real similar to it, though, right? Wasn't it? Yeah, go ahead. Oh, yours was, but it wasn't 7 pi over 12, though? No? Okay. Let's try this one here, y'all. And again, I just want to make sure that we're doing okay with this problem. And this one here, I want to go through. I'm curious to see if we're going to get something like what Christian had the other day. What do you think my first step would be? Convert it to degrees. Okay, so that and that are going to cancel. This goes in here 15 times. 7 times 15 is 105. Okay, so take a look. Look what it says. Use either the addition or the subtraction. So even think about the one that we did a little while ago, Thomas. See how it gave me the negative 255? The first thing we did, we didn't have to convert it to degrees because it's already degrees, but we said, look, I can use at least that even and odd business, right? I'm not going to have to worry about that here because I'm already looking at a positive number, right? So now, if I come back over here and I say, look at we want to get 105. 60 plus 45, right? Could you do it by subtracting? Yeah, couldn't we do 150 minus 45? You could do it like that too, but intuitively, you said 60 plus 45. Stick with that. Stick with what comes like naturally to you. You know what I mean? So look, we're going to say cosine of 60 plus 45. And because we just did one like this, y'all, this is going to be my formula. Okay. Cosine of 60, so I'm going to come back over here. Cosine of 60 is 1/2. This here is the square root of 2 over 2. Sine of 60 should be square root of 3 over 2, and this is square root of 2 over 2. And so this is giving me the square root of 2 over 4 minus the square root of 6 over 4. So, yeah, Christian, I don't think I'm going to end up with something like what you had the other day. But I'll show you guys kind of the way his problem was set up and why it was different. But this is what I'm coming up with. Square root of 2 minus square root of 6 all over 4. So again, I'll come back over here And let me do my fraction. Yeah, square root of 2 first. Sorry, square root of 2 minus square root of 6 all over 4, and we'll check it, and we're good. Okay. So the one that Christian had the other day, his problem was something like this. Like it was like a, I don't remember, but it had something like this, right? It was something along these lines, and it was counting it wrong. And the way that they put their answer in was they did it like this. See how each of these here have a negative? They factored out that negative to begin with, right? And I don't know why it was so finicky, but it was. But let me do this real quick. We come back over here. That was number what? 18. Let me go continue. So real quick, hold on. So my point though is if that problem is that if that question that was number 18, right? If that question was on your test, it's going to be a lot like something like this. You know what I mean? So even if I do try another, was it this one? Was it negative 13 pi over 12? Okay, so look, it actually came up. Let's do it to it, and let's see if that's how it's going to give me the answer. And we'll do it both ways, but I think I'm going to have to be real picky with it. I wish it wasn't as finicky as it's being. So first thing I would do here is I'd say, look, let's think about this as the cosine of 13 pi over 12, because we can use that even in odd business. And then just like we did a little while ago, we take 13 pi over 12 times 180 over pi, cross that with that. 12 goes in here, 15. Let me grab my calculator and figure out what's 13 times 15. 195. Okay. Cosine of 195. So then I'll come back over here and I'll ask you guys, how do you think we could come up with 195 using those numbers on the left-hand column? 240 minus what? Say it again? 45? Yeah, so look, let's double check it. You said 240 minus 45, 195. Okay, so let's do it. 240 minus 45. Okay. So now, y'all, since we're using the cosine of a difference, I'm going to use the difference formula now. I'm going to use this one. Look at the only difference between the one that we were doing before and this one. Before we used to have a minus, now we have a plus. Okay. So we're going to say this is the same thing as cosine of 240, cosine of 45, plus sine of 240, and sine of 45. Okay, so let's use our table here. Let me come back, let me get my table. Come back over here. Alrighty. And we're looking at the cosine of 240, which is negative 1/2. Cosine of 45 is square root of 2 over 2. Sine of 240 is 240 negative square root of 3 over 2. Sine of 45 is square root of 2 over 2. Okay, so look at how I'm writing my answer. Guys, I want to point something out. Again, just because Alex is so finicky. Running like this essentially means we took that negative and we factored it out of everything, okay? But I'm going to first enter my answer in like this and see if it takes it. Okay? And I hate the fact that it's that finicky. I really don't like it either. Okay, so we had a negative square root of 2 minus square root of 6. Okay. So negative square root of 2 minus square root of 6 all over 4. We're going to go like this. We're going to say check it. And it's saying, no, that's not right. Okay, so look, this is what I'm going to do. I'm going to take that away. Take that away, put a plus. Well, that's why I'm doing it right here, right? That's why I'm doing it right here. I'm hoping this is kind of like, okay. So now look where we put the negative, we put it out the very, very, very front. Let's recheck it. And, oh, it's still telling us it's not right. ¿Por qué no? Huh? On the thing? And it's the same? Negative 13 pi over 12? Why is it not coming out right? It's the same one. We're just doing the different variations of it. And Kristen, I'm sorry. What's the answer that you came? What's the right answer according to that? It's looking like this. Okay, yeah, but yeah. And the negative, is that negative out there in the very, very, very front? So even though we're doing it right, because they put in the 6 first? Is that what?
So crazy. What?
I'm gonna try something here. I'm curious if that's the problem. But look.
What? Am I blind?
And this is exactly what it did to you, right?
This has to be a bug.
This has to be a bug.
Is there like a, you put a space anywhere?
I think so.
I didn't even think it left you, right? Crazy. Screenshot.
There's okay, so I don't know how it works on Alex, but on my lab there is, yeah, on my lab there is an option for, well, it's not necessarily customer support, but like if there's a if this happens, I'll tell you what, guys. When you take your quiz, you don't know if the answers are right or wrong until you submit it, right?
Yeah.
Okay, same thing is going to happen when it comes to the test. So let's put it this way: you come to the test. I'm not saying this question's on there, but if this question were on there and you did it right, but it counted it wrong, take a picture, send it to me. I can give you credit for that. You know what I mean? Yeah, it's just one of these things. Yeah.
So, like, the reason I asked is because I was wondering if you were going to put my calculator answer.
What did your calculator answer?
It's parentheses,
Uh-huh.
negative, open parentheses, square root of 3 minus 1 times square root of 2. Square root of 3.
Hold on, say that again. But you're doing a different problem though, right? Yours is, you did cosine of negative 13 pi over 12?
Yeah, which is, negative 13 pi over 12.
Yeah, I'm gonna try one more thing. I don't know why this is coming out so crazy. We came up with 95 or 195. I wanna see something here. If I did the cosine of negative 195, it shouldn't make any difference. It really shouldn't make any difference. I just think it's a bug or something. 195. Yeah, but instead of the addition, Yeah, so we could do that. So if we were gonna stick with our 195 positive, couldn't we have said 60 and 135? Okay, so let's do that. Let's see what happens. If we say, oops, if we say this is cosine of 60 plus 135, that would give me cosine 60, cosine 135 minus sine 60, sine 135. And then if I use my table, cosine of 60 is 1/2. Cosine of 135 is negative square root of 2 over 2. So 1/2 negative square root of 2 over 2 minus sine of 60 is square root of 3 over 2. Sine of 135 is square root of 2 over 2. Square root of 3 over 2, square root of 2 over 2. Negative square root of 2 over 4 minus the square root of 6 over 4. Isn't that what we basically had? So we had, look, we had it like this, right? Which is exactly what we have here. I don't know. I don't know. It should, I mean, it shouldn't. It has to be like a bug of some kind. You know what I mean? It has to be something like that. So, yeah, for whatever reason, guys, if you end up with something like that, you know what I mean? What I mean for you is this: whenever you're done with your test and you submit it, if you have the right answer, but it counted it wrong, like in Christian's case when he did that particular problem, I'll be with you in a second. Let me know. I can go in. I should be able to give you credit for that problem. It's just going to be a fluke, okay? But if that happens, just let me know. Yes, sir. Yeah, it'll be just like when you submit. Yeah, yeah. After, but it won't tell you at that time. It'll tell you when you submitted it. Yeah. So guys, if something like that happens, just let me know, okay? Just let me know. Yes. Bless you. Yeah, but see how look what they did. So guys, I'm going to show you when on John's calculator. This is how his calculator wrote it. Good.
I have it on Saturday.
Yeah, yeah. No, you're good. You're good. It's factored, right? So look, if you do this, wouldn't you end up with that? Right? And then if we distributed that, wouldn't that give me the way this is exactly how John's calculator wrote it, right? So what the first thing I did is I said, look, let's distribute that square root of 2. So we get square root of 6 plus square root of 2. And then let's distribute the negative, and we get the same thing that we had up here, right? Yeah, I just think that on that particular problem, it's just kind of it's a bug. You know what I mean? It's just, I'm sorry? I have to keep doing the problems until I get that same variant. You know what I mean? So I don't want to spend too much time going over that. I mean, we know how to do the problems. It's just, whether it's giving me an issue or not. Right? Guys, what do you think? You know how to do it? I'm going to go over it. We're good? Okay. What about something like this? We're good with this too? You got this one here too? Are we good with it? You want me to go over it? Anybody? 21? Yeah. How would I do this problem here? What do you think the first thing I should do is? Yeah. What quadrant are we in? 4, right? So we'd come back over here and we'd say, boom, paste it. Yeah, so the y is going to be negative because we are in quadrant 4, right? So my picture would look something like this. Yeah, so think about it this way. No matter what quadrant you're in, guys, r is always going to be positive. The only thing they're going to change, the only signs that are going to be positive and negative, or they could be negative, will be your x and your y, right? But the r is always going to be positive. I'm glad you asked that. The r is always going to be a positive. So look what it says. Sine of theta is negative 12 over 13. Y'all agree that this is a negative 12, and that has to be my 13? So we're going to find our x value, right? Just like we did before, y'all. This is my Pythagorean theorem, right? So let's see, x squared plus, 12, or negative 12, I should say, squared equals 13 squared. 144? It's 169, very good. That's 25. So what do you think x is going to be equal to? Positive, right? Everybody agree it's going to be a positive 5? Because in quadrant 4, x is positive? Okay. So now, look at what the question is asking us to do. The question is asking us to find the sine of 2 theta, right? So anybody remember the formula for the sine of 2 theta? Okay, so look, all you got to do, y'all, come back over here. Scroll, scroll, scroll. Here's my double angle. There you go. 2 sine theta, cosine theta. So 2 sine theta, cosine theta. So 2 sine theta, we already said was a negative 12 over 13. What's cosine? Oh. So let's see. That should give me something like a negative 20 over 169. Okay. So I'll come back over here, come back to my problem. Let's do a fraction. Negative 120 over 169. Okay. And then let's do the next one. So cosine of 2 theta. That's one that has 3 different formulas. That's right. Yeah, so we can come back over here and we can say, look, cosine of, we can do this one if we want to, cosine squared minus sine squared. So cosine squared theta minus sine squared theta. We already said cosine was 5 over 13 minus negative 12 over 13 squared. Oh yeah, squared them both, sorry. That's 25 minus 144 all over 169. So what's 25 minus 144? Negative 119, thank you very much, over 169. So we'll come back over here. Oops, yeah, and we'll say negative 119 over 169. Okay. And then we got one more. We got to do the tangent of 2 theta. Yeah, look at the tangent 2 theta formula right there, right? 2 tangent theta over 1 minus tangent squared. So we're going to go 2 tangent theta over 1 minus tangent squared theta. Okay, so let me come back so we can look at our picture. What do you think the tangent of our angle is going to be? What's the tangent of theta? Negative 12 over 5, right? There's our tangent theta. Okay, so let's come back over here. So we're going to have 2 times negative 12 over 5 over 1 minus 12 over, or negative 12 over 5 squared. Okay, so guys, if I multiply that, that should be a negative 24 over 5. 1 minus 12 squared is, 5 squared is 25, okay. Here? No, because think about it like that. 2 over 1, right? Okay, good, good. Yes, sir. Negative 12 or negative 24 over 5. Guys, can we think of this here as yes. So we got 24 over 5, and that's a negative 119. over 25. Remember how we divide fractions of the denominator? So that's 25 over a negative. Okay. So y'all agree first off, negative and negative cancel? 5 goes into 25. Okay, so we're going to take 24 times. No, 24 times. I'm sorry. Go slow, go slow. I know I'm probably going too fast, so I'm going to slow it down. 120. So 120 over. Boom. Then we'll come back over here, and we're going to say, here's my answer. 120 over 119. We're going to go check. We got them all right? Okay. Multiplying. Distributing. So look, guys, it's 4 o'clock now. Do you want me to save these last 7, 8 problems for later, for Monday? Y'all want to do that? And then Monday, after we're done with chapter 6, we can go over these problems here. Okay, so let me go ahead and stop sharing this. Let me come back over here. Let me stop recording.